So our function is that they give us is g of x equals the integral from 1 to x of f of t dt. And they ask us for g of 2 and g of negative 2, so we'll do those two separately. So for g of 2, so this means that since this is our x, and we're saying the x is 2, that means that that 2 is going to go up here for this x. So all they're asking us really to do is find the integral from 1 to 2 of f of t dt. Now, if I had a function, I would get an antiderivative and use the second part of the fundamental theorem of calculus. But I don't have a function. Instead, I have a graph. So I need to look at the graph and find the integral from 1 to 2. So here's x equals 1, and here's x equals 2. So one important thing to know is that these limits, 1 and 2, those are x coordinates. So we're not looking for 1 and 2 on the y-coordinate. We're looking for this. This is our interval that we're integrating. And we need to know the area under the curve. Or sometimes we say the area between the curve and the x-axis. We also need to remember that if we have area that's below the x-axis, then that area is going to be negative. Whereas if we had some area above the x-axis, that would count as positive. So our area is below the x-axis, all of it. So we're going to need to know that all of this area down here is going to count as being negative. So we need to look at this triangle and try to get its area. So we know that this is equal to this negative area down here. So we're going to say it's negative 1/2 base times height because we have a triangle. Now we know the base of the triangle is 1. But we need to find the height of this triangle. They didn't give it to us, and we can't really estimate. But now we're going to take advantage of the fact that we know that this is a line segment. It says consisting of 3 line segments. That means the slope is constant here. So if I look at the change in x from here to here, and the reason I'm picking to here is because this is where we have an x and y coordinate to compare. Well, the change in x from here to here is 2 because we went from 1 to 2. And the change in y was we went from 0 to -1. The change in y is -1. So that means that we know that the slope of this line segment is delta y over delta x, so it's -1/2. So now we know that if we move over 1, we're going to go down 1/2. So all of that work was to determine that the coordinates of this point right here are 2, 1/2. Now we could also do that by saying, well, sorry, that's -1/2. So we could do that by saying the average of 1 and 3 is where this x equals 2 that we're interested in is. So the average of 1 and 3 is 2. So we know that this is x equals 2. And that means that since the slope is constant, that the y coordinate is going to be the average of 0 and -1, and the average of 0 and -1 is -1/2. So all of that is so that we know that the height of the triangle was -1/2. Or since we already said the area is negative, we're going to say that our height here is 1/2. So we had to do a little bit of work, a little bit of interpolating off our graph to find out that the height of that triangle was 1/2. Then once we've got that information, we can just work this out. So that's -1/4. So now I know g of 2 is -1/4, and that's all I have to write for that problem because they didn't ask me to justify or explain anything. Now, the next thing that the problem asked me for is for g of -2. So now we're going to find g of -2. G of -2, and that just means that instead of putting 2 for the x, we're going to put -2 for the x. So that's the integral from 1 to -2 of f of t dt. Now the first thing you need to notice about this integral is that the upper limit is lower than the lower limit, and we can't have that for an integral. You can have it, and some people write it that way, but it's essentially not a proper form for the integral. So what we need to do is reverse these two limits, and we're going to do that by putting a negative sign outside. So we're going to put a negative outside, and we're going to change the limits from -2 to 1. And now that's our integral. So now we need to get a handle on this part because this is going to be the area between f of t and the x-axis, and then we're going to have to account for this negative sign at the end. So let's look at this area between f of t and the x-axis. So now we're going from -2 to 1. So now our new x-coordinates, our limits again, our x-coordinates, are from -2, and this time they were nice enough to give us the y-coordinates, so that's going to be not quite as much work. And then we have to get to 1. So this is our interval over which we are integrating. Now, the part above the x-axis has to count as positive, and they want to make sure that we understand this. And then the part that is below the x-axis counts as negative. So what we're going to have to do is the triangle minus the circle. Now that's what the area between f of t and the x-axis is. So for the triangle, we have 1/2 base times height. So that's going to be 1/2 base times height. And then we're going to go minus the circle. That's a semicircle, so we're going to go minus 1/2 pi r squared. And we have to have this negative sign out in front of the whole thing. So that's what our integral now equals. Now we can just plug in some of our values. So that's negative, let's see, 1/2. So that, referring to the base of the triangle, the base of the triangle is 1. So that's 1. Height of the triangle is 3. So that's 3. And then minus 1/2 pi. And our r is the radius of the circle is 1. So that's times 1 squared. And that looks like we've accounted for everything here. So now we can just go ahead and work this out. So we get the opposite of 3/2 minus, looks like this is just going to be pi over 2. So I can distribute this negative sign, and I'll reverse the order of the terms and just get pi over 2 minus 3 over 2. Now actually, by the way, once we're here, we have a completed AP response. So if we have this, we've already gotten full credit for the answer to that question. The rest of this, we don't need. That's just a little bit of a habit on my part. So we can write this answer and it's nice, but this is what we need for AP. This is what you would need to show your college professor. The same goes, by the way, for G of 2. I could have left this problem here. I've got full credit right there, as long as I don't have any variables in. So it's nice of me to put the -1/4, but it doesn't get me any points to do that. And in fact, if I get it wrong, it might cost me 1/2 point. So I want to finish here and finish here for my AP free response question. And now let's just check and make sure that I've answered the question. So the question says, for part A, find the values of G of 2 and G of -2. A good idea, once you've finished a problem, look back at the question and say, did I answer this question? Did I say what G of 2 was? It's -1/4. Did I say what G of -2 is? It's pi over 2 minus 3/2. Or I could just say it's -1/2 times 1 times 3 minus 1/2 pi times 1 squared. I could say it's that. So I have answered that question. And it did not ask me to justify or explain, so my work is fine. All right? That is part A.